Let's talk about compound inequalities. We're going to talk about a real simple concept first. What is the difference between these two phrases? One says Mr. and Mrs. Jones. The other one says Mr. or Mrs. Jones. Okay, one of them is inclusive. That means it has to be both Mr. and Mrs. Jones. The other one gives you an option. It can be either or. Now, this makes a big difference when you're writing a check. If you're writing a check and it says Mr. and Mrs. Jones, then both Mr. and Mrs. Jones need to sign the check and show that they know what's going on with it. If the check says Mr. or Mrs. Jones, then either one of them can do something with it. So that in the legal world, that's pretty important. When you combine two simple inequalities together with the words and or, the result is what we call a compound inequality. Now, the word and means both situations have to be observed. The word or gives you a choice. There is no choice with and. Everything has to be included with and with or you are given a choice. So, let's take a look here. If I have x is less than or equal to 2 and x is greater than -4, that means that this would be 2 would be my focal point on this end, -4 would be my focal point on this end, and it basically would be everything in between here. Okay? If it's x is less than or equal to 2, that means it includes 2 and everything down below it. X is greater than -4 means it does not include -4, but everything above it. Now, let me show you something. If it's an and situation, you actually can take it and take the one that has the smaller number and flip it over. You'll notice this flipped over looks like this. And then take the larger one and just put it right on top of it. And you can actually make a compound inequality where it has two inequality signs in one equation there. If we change the and to an or, then we give choices. In this case, it says that x is less than -4 or x is greater than or equal to 2. We simply put these on a number line and whatever is there is there. They don't have to cross over. Whereas with the and situation, we're looking to where they cross over each other. We're looking for an area that is inclusive there. So in this case, x is less than -4 would be an open circle at -4 and an arrow going to the left, or x is greater than or equal to 2 would be a closed circle at 2 and an arrow going to the right. Your solutions to this compound inequality would be anything in this arrow area or 2 and this arrow's area, but it will not be anything that's in both. This diagram, this is called a Venn diagram. And A here represents all of the values that are less than 10, so a representation of numbers that are less than 10. And B represents numbers that are greater than 0. You see the overlapping region right in here, this part right in here, are numbers that belong in both of those ovals. That's the and situation. You're looking for the overlap there. Okay? You can graph the solutions to those on number lines. This would be the number line for x is less than 10, open circle at 10, arrow going to the left. This would be the graph for x is greater than 0, open circle at 0, arrow going to the right. And the and compound inequality here would be this graph here on the bottom. You only graph the part where these two graphs overlap. All right, so let's solve some. Here we go. If you go back to solving equations or inequalities, we talked about putting a wall there. Well, here, there's a wall here and a wall here. If you see it written like this, you know automatically it's an and situation. They are the only ones that can be written with the double inequality signs. So I want to isolate the x. To isolate the x, I'm going to have to subtract 1 from the middle section there. That means I have to subtract 1 from both of the outer sides. This is going to give me negative 6 is less than x, which is less than 1. Okay, now again, when I graph that, this would be the graph of x is greater than negative 6. This would be the graph of x is less than 1. And this would be the graph where they overlap. Okay, and again, this is the only one you have to do is this one right here. I like the way this is set up because basically this is an endpoint and this is an endpoint. And since these are both less than signs without the or equal to, they're open on the ends. Great, let's try this one. Let's put a little wall here, put a little wall here. We're going to add 1 in the middle to start this, so that means we add 1 to both of the outer edges. That gives me 9 is less than, 3x, which is less than or equal to 12. And now we're going to divide the middle by 3, which means we have to divide both the sides by 3. And we get 3 is less than x, which is less than or equal to 4. Okay? So if this is 0, 1, 2, 3, 4, to graph that, my lower edge is going to be at 3, and that's just less than, so that's open. My upper boundary is going to be at 4, that's or equal to, so it's closed in. And basically, x is everything in between there. This Venn diagram shows you in A, all the values where x is less than 0. And then B shows you the values where x are greater than 10. And you'll notice that there is no combined shaded regions that are an overlap. So since this would represent an or situation, the solutions could be in either circle A or in circle B. Okay, so that's what this one is. This is called a union. Okay, the other one was an intersection. Now here, all you do is you simply graph both of them on the same number line. So here's the first graph of x is less than 0. Here's x is greater than 10. You just put both of those graphs on the same number line, and that's it. So when you go to solve these, you're going to always see the word or there. There's no way that those two inequalities can be merged together. They are two separate conditions. So for this one, we would simply solve it by subtracting 8 from both sides and get t is less than or equal to negative 1. That's going to be a closed circle at negative 1. I said less than, it's greater than. T is greater than or equal to negative 1. Arrow goes this way. The second part of this, you would subtract 8 from both sides, and you'd get t is less than negative 6. So that's going to be an open circle at negative 6 and an arrow going to the left. And again, the solution to this compound inequality could be anything in this area here or this area here. Either one of those would work. All right, again, you're going to see the word or here. So this is going to be minus 2 from both sides. R is less than 10. So that is going to be, I'm going to need a different graph here. That's going to be an open circle at 10 and an arrow going to the left. For this part over here, we're going to subtract 5 from both sides. That's going to give me R is greater than 14. That's going to be an open circle at 14 and an arrow going to the right. Okay, again, let's summarize what's the difference between and or. And means it has to include both of the conditions. When you do this, this is an intersection. Okay, and you're going to graph only where they overlap. Okay, and you have to meet both conditions. The word or is going to be a union or a combination of the two. Okay, a union. There doesn't have to be an overlap. There can be an overlap, but there does not have to be an overlap. You simply graph both of them on the same on the same number line. And it gives you a choice. Either one of the conditions can be met. Okay, now really quickly, we're going to finish this up by writing inequalities. Okay, in this case, since there is no overlap, you know for a fact it has to be an or. So this one is what? X is less than or equal to -8, or this side would be X is greater than 0. In this case, you can tell that it's going to be an and if it's going to be an and, it's really easy to write. Put the end point here, which is -2. Put the other end point here, which is 5. Both of these are open circles, so they're both going to be less than signs, and X is everything in between them. And that's it.